Yeah, so in week 4, like I said, what was covered was like how to use Python for machine learning applications to predict stuff like for real life applications. So in today's live session, I will just be explaining very briefly about the models that were used, like the principle behind it, and I'll walk you through the course, I mean, like what was taught on week 4, like all the exercises. And towards the end of the lecture, I'll also be solving week 4's assignment from previous year's question papers. So that'll give an idea of how to solve your current assignment as well. So yeah, let's get started. I hope I'm audible and you could see the screen. Yeah, it's fine. Just checking if you can see the screen. So yeah, like these days, these terms have become very fancy, machine learning, AI, and all that. So the concept is basically simple. So we already have a lot of data sets that have been recorded, like for example, like census, the weather patterns, and the stock market, the prices, and how the uh, rental, I mean, the house prices, how all these have been fluctuating. So there's so much data that we generate in all kinds of fields, and all these data have been documented and stored. So in machine learning, what we do is we just use these available data and we train models, which is essentially the machine, in our case, like our computer, using Python, it's trying to read the data that's already there, and it's trying to recognize the patterns, the trends in these data. Like, for example, if we are looking at predicting house prices or the rental prices. So what is the rent dependent on? So rent is usually dependent on the locality, the type of house, the number of people who share the compound, and what else? The amenities. And yeah, by locality, we mean whether it's in the major like city center, like all other uh, shops and hospitals, facilities are nearby, all these factors. So yeah, like it'll just try to learn these datas that we have inputted, and it'll try to see if there's any trend, and it'll learn that. So it'll understand that. So as if the house is in a like good in the city center, the price is high, and things like that. So the machine will just learn it. And based on this data, when we input our own data set, which in programming language we call test data set, this model will be able to predict the price. So yeah, that is the overview of machine learning. That's the idea of it. So what is it is it's basically like, I'll just briefly go through the steps. So collect data. Like we don't have to generate this data. All this data would be available somewhere. So you just collect the data, and then data pre-processing. By data pre-processing, we mean, what do we mean by that? So there's a lot of missing value, like handling missing data. That is one thing. And dealing with outliers. So let's say we're looking at data between 1950s to 2020. So we are looking at how many cars have been registered. Like that was the example that uh, was used in the lecture. So yeah, if you look into the data set, like in olden days, in earlier times, there were not so many cars that were registered. So it's okay to exclude those data. So those are just outliers. So yeah, we need to like look at the data set, and we need to like make some distribution plots. And it's just kind of like a trial and error thing that we do to decide what data range we work with. So outlier handling, is one thing. Like basically it comes under data range. We set the data range. So yeah, so these are the major things that we do in data pre-processing. And what we do next is we split the data into training data and test data set. So this is used to build the machine learning model, ML model, and the model performance is evaluated. But yeah, we'll go to that. So basically what we mean by this is we already have a data set. We know the price and everything. We're trying to predict price. Let's say we're trying to predict price with other variables given. So we just split this data into training and test data set. Here we already know the price, right? So what we do is while training the data set, the machine just learns this data, like this data. And then as a test, it uses this data to predict the price. And then as part of model evaluation, we use this predicted price and compare it with the actual price. And we calculate parameters like accuracy. Like accuracy gives a I'll go through these terms next. So there are many other things that can be used to evaluate the model, like accuracy, precision, and recall, and fit, error, like so many such mathematical terms. So when the model is evaluated, we use that as the actual model, and then we use our own real-time unknown data set. Unknown data is inputted, and then the predictions are made. So this is the whole idea of machine learning. Yes, this is the latest session, like the fourth week, the last week of your course. Okay, so we have seen briefly what's in machine learning. So generally, these tasks that we would face is like, what do we need to predict? So usually we might need to predict a continuous range of values. Let's for a continuous data, discrete data, or categorical data. By continuous data, we mean like continuous numbers. It could be any number. It could be like 100. It could be 101. It could be 101.5. It could be 101.05. So it could be any such a number within like a continuous spectrum. So this could be like temperature recorded. Like what will be the temperature in June at this particular location. So how is this done? Like you have the temperature like for the past all the years, and the model is built with that. And then when you like ask for a given place and a given month, it's able to predict it. So like temperature data, price, like price, rent, price of something, rent of a house. Yeah, like all such things that would involve such continuous values, continuous numbers, like it's continuous data. And what could also be predicted is categories. Like good examples would be, so does the price fall above a particular value or below? So these are two categories, right? So this is one thing. And the salary, like above, like monthly salary of above 50,000 or below 50,000. So such like predicting events in like that where the outcomes could be two or more categories is basically the ones involving this kind of data. So like based on this, we have classification and regression. So regression is the term. It's basically for predicting continuous variables. And classification is a method that's used to predict categorical variables. Yeah. So these were the two topics that were demonstrated, like how to predict this. So the examples that were given were predicting the income, example in lecture, predict income category. Here, what example was used was predicting the resale price of a used car. Yep. So there were multiple models that were also demonstrated for you. So I think those were linear regression was covered in week 3. It's just basically like doing a scatter plot and trying to fit a line. And then what was covered in week 4 was logistic regression. K neural network, random forest. Random forest can be used in this case as well. Just okay, so I just briefed about categorical variables and like the predictions that can be made with those. So categorical data can also be bivariate or multivariate. Like by this I mean that the outcome could either fall into two categories or multiple categories. So this is one thing. So I can also just give an overview of what each method is. So linear regression is basically used for like numerical values, continuous data, and the relationship is linear. That's why you call linear regression. It could be either like this or either like this. And these are the training data points. They all And let's say like my test data point falls somewhere over here. So based on the prediction and where it falls around the line, it's able to predict where this data would be. So this is just simple overview of linear regression. So logistic regression, that's so as the name would suggest, like logistic. So this is mainly, okay, let me write it. Logistic regression. This is specifically useful when you deal with problems. It's ideal for binary classification problems which have a linear decision boundary. So it works based on probability modeling, and it's easy to interpret as well. So what we mean here is, let's say the trend between two variables is linear, and above this line there's like this one category, it always falls above this line, and another category, it always falls below this line, like this. So in such cases, so this is what we mean by binary classification problem. So we have two categories. Your output can either fall in category 1 or category 2, and the decision is basically like linear. Like if it falls here, it belongs here. If it falls here, it belongs here. So this is when logistic regression works well. And there's one more thing, like KNN that was covered. It's the abbreviation for K nearest neighbors. K nearest neighbors. So K is something that you define. You can, based on your data set, you can decide whether to look at the 5 closest neighbors, or you can also look at 20 closest neighbors. Or if it's a very large data set, you can look at 100 closest neighbors. So what we mean by that? So this is specifically useful when this is effective for smaller data sets, or when the decision boundary is complex. Small data sets, complex decision boundaries. So let's say like for biologists, like people who are doing like biology or any like biological science, you must know something that about gene expression and cell types. So there are different cell types in our body, and each of these cell types, they have distinct gene expression profiles. So based on the gene expression profiles, you are able to cluster each cell type separately. So let's say these are the different categories we have. Like all cells of cell type 1 will be clustered together somewhere here on your graph. And cell type 2 will be here, and so on. And let's say our test data set lies somewhere. Let's say it lies here. So by k nearest neighbors, what does that mean? So if I say 5 neighbors, it will look at the 5 closest points around this. So if you look at this, what are the 5 closest points? So it computes distance between every point. Like this is one distance and this is one distance. So based on that, it identifies the 5 closest point. And so basically this test data set will be grouped along with this cluster. So this is the idea of k nearest neighbors. It looks at the closest points and it will be assigned to the, like what, it'll be assigned to its closest match. And then random forest, this is a method that this is powerful for both classification and regression. Random forest, I'm abbreviating it as RF, for both classification and regression problems. And it handles large data sets well. and it also handles non-linearity well. Yeah, so when we spoke about logistic regression, like this line, the relationship might not always be linear. So it could be like a linear relationship, or it could be a non-linear increasing relation, something like this. This is non-linear, but it's still an increasing, like positive relationship, right? So logistic regression doesn't handle this well, but random forest, it handles such non-linear relationships well. And it also helps decide, let's say we have yeah, let me just use the other slide. So this is what we need to predict. We need to predict the dependent variable. In our case, it is price. Like just for example, let's say price. And price of, like, let me just speak using the example that was shown. Price of the resale price of a used car. So several factors will be how much kilometers it has been run through, and fuel type, like age of the car, like how long has it been since the car was purchased, like several other things. Like all these are called independent variables. Independent variables. So there could be like so many independent variables, but all these variables might not necessarily contribute to, oh, yeah, sorry. So yeah, we have so many independent variables. So all these variables might not directly correlate or directly affect the prediction of your dependent variable. So probably like kilometer might be an important factor, age might be an important factor, but there might be several other variables that might not significantly affect whether or not the price is high or low. So random forest, what it does is it it tries to use or drop several variables, and it can also decide which variables are uh, important for the prediction of the variable. So yeah, that is one advantage of random forest. And okay, so this was basically like the theoretical part of it. Now, okay, so let us, oh, I think, yeah, I think I missed something. Okay, yeah, I'll just explain like when I walk you through this. Yeah, it'll be great if you all could stop scribbling so that it'll be easier for me to explain or elaborate with the pen. If you keep doing this, like, yeah. Okay. Yeah, so first, classifying personal income was the case study that was handled, and we first used KNN method for building the model. And yeah, the first step as usual is to load all the necessary libraries. So pandas, Seaborn, yeah, and the one new library here is sklearn, is scikit, scikit-learn. So that's the like go-to library for all this machine learning models. So yeah, it's just abbreviated as sklearn. So you import several packages from that. Yeah, I'm not gonna run everything. I think it's already run. I'll just like walk you through the steps because this is the exact same thing that was in the lectures. So if we are reading the file, we are seeing like all the missing values and we are dropping all the missing values. So all this like file pre-processing and how to like handle missing data, all this were already covered in week 3. So yeah, I believe like you wouldn't need a lot of explanation on these. So yeah, one thing is here what we're doing is, so here what we want to predict is the salary status. So this is what we aim to predict using these models. So by salary status, we want to predict if somebody earns less than or equal to 50,000 or greater than 50,000. So one thing is all these machine learning models, they don't understand such like categorical data, like as such, they don't understand them. So you would have to encode them. By encoding, I mean like let's say you make like less than 50,000, you just encode it as 0, and greater than 50,000 you encode it as 1. So it always has to be binary, like zeros and ones. So that's what we're doing here. We're just replacing the column, like we're mapping it. So if this column has less than or equal to 50,000, we are making it 0, and if it has greater, we are making it 1. So this is one thing. And the same thing, even the rest of the columns. So this is for training purpose. Rest of the columns also, like here, for example, the countries were the native country column, it had Portugal, Scotland, it had Taiwan, it had Thailand, and all that. But yeah, since the computer country, machine can't read it, we are like splitting these columns. We are making these as separate native country underscore whatever country it is, country A, country B, country C. And if the person like he belongs to Portugal, this column is encoded 1. Otherwise, it's 0. Yeah, so that's how like every variable is being encoded here. And now what we're doing is we want to predict the last column. So this is what we wanted to predict, sal stat. Everything else, we can use it for the training data set. So we are basically splitting the data set as X and Y. So X is all the uh, independent variables, and Y is the dependent variable that you need to predict. So that's what we're doing here. Features, we're just selecting the columns here and then we're creating X and Y. And now what we're doing is we're splitting X and Y further into X train, X test, Y train, and Y test. So mostly how you do that is you just specify the percentage of your test. So let's say I want 30% of my data to go to the test data set so that I can evaluate my model. So usually the test data, it ranges around like 20 to 30. So here we're using 30. And random state, it can be any number. So it just means that when I rerun this program, yeah. So basically, when I say when I specify test size is equal to 0.3, 30% of the data will be test. So when I use the same number the second time, the same 30% of the data will go into the test category. So that's what random seed is. So if I use 0 now, let's say row number 1, 2, 3 will go to the test data set. And second time when I run the same, and when I use the same random state 0, the same 1, 2, 3 will go into test. But sometimes, let's say I specify different random state 5. In this case, like 5, 8, 9 might go into the test. So that's what random state is, just for reproducibility. It's so that like when I run it multiple times, the same data goes into the same categories. So okay, and we went through. So yeah, all these, like this is the command that you use to run k nearest neighbor. You're specifying the number of neighbors you want. You're fitting your train and your training data set X and Y. You're basically fitting it. And then you're predicting you're predicting the test values with a model. So you're using test X and you want to predict test Y. So test Y, we already have test Y. Those are the actual values for Y. So the training data, it used to fit this model. And your test X, some random points around, it used to predict. So your test X was used to predict some Y value, right? So that Y value we store into prediction. So whatever is predicted. And then you have your actual Y values were stored in test Y. So now you compare your predicted Y and your actual Y. So this is basically model performance evaluation. You compare your actual value with the predicted value with your actual value. Yeah, so how you do that? You like we're using a confusion matrix. What it gives is, it gives you this. So what that essentially is it's true positives and true negatives, false positives and false negatives. So these are the important things. So like when you first look at the confusion matrix, you look at these. So this tells you how many values, how many correct positive values were correct. I mean, like how many values were correctly identified. No, let's say greater than 50K was encoded 1. Less than 50K was encoded 0. So here we consider 1 as positive, 0 as negative. Like just the computer takes it like that. So here what it says is how many such positive values were correctly identified as positive. So those are true positives. And then how many negative values were correctly identified as negative values. And false positive is how many negative values were wrongly predicted as positive. And then how many positive values were falsely predicted as negatives. Yeah, like if you just think about it, like it'll make sense. Like, but you just remember the structure: true positive, true negative, false positive, false negative. So here you could see that like 650 were and 843 they were predicted. So a model with 100% accuracy, it'll have like it'll have 0, 0 here in these off diagonal elements. It'll have 0 and 0. Like only your diagonals will have the values. That is like 100% accurate model. So accuracy, so we calculate the accuracy score. Accuracy of what? Accuracy of your predicted Y values with respect to your actual Y values. So this tells that 83%, 83.5% of the times your model has correctly classified your has correctly predicted your Y value. So accuracy basically by definition is true positives, like the number of true positive identified, like divided by the total number of predictions. Um, so we do the same classification problem. Here we used K nearest neighbor model, and now we're doing the same thing with logistic regression. The same things you do here, but this is just some stats that you're visualizing that you could go through in your own time. Oh, here you could see you're doing the same steps here. That was just some visualization for you to understand the trend of the data. We are doing the same thing here as well, like you're creating X and Y. So Y would basically be the sales stat that you want to predict. And again, you're splitting test train data set. You're doing the same things here. Like you're fitting the model and then you're predicting Y using the test X. Again, your confusion matrix. Again, you're calculating the accuracy. You could see that this logistic regression is slightly better. Yeah, earlier KNN, it gave you 83.5% accuracy. This gives you like 0.1% extra accuracy. Yeah, it's just so not very significant, but yeah, that's how you compare models. So when you're building a new model and this is how you do. You first build multiple models and you see which performs the best, and then you finally use that to predict your actual values. So this was done using all the independent variables. And so in this lecture, what they had shown is you also rerun the model by removing insignificant variables and you see if the accuracy improves or if it's the same or if it drops by so much. So what do you mean? So yeah, how do you identify these insignificant variables? So that's when you do all the distribution plots. So we'll go more detailed into that, like when we look at the next example, like how you look at the plot and tell whether this variable is significant or insignificant. So here the next scenario was predicting price of pre-owned cars. So this is like you're predicting the price, which is a continuous variable. Here I think we use random forest here and regression as well. Yeah, let's see. So as usual, you're reading the data. You're just like looking at what is in the data and all that. So you're dropping unwanted columns that you think is not important. Like all this date is not very necessary to decide whether I sell it for $1,000 or for $500. So here what they're doing is they're looking at the range of the data sets. Like they're looking at the range so that so if you remember, we spoke about removing the outliers and fixing a data range. So for that, you basically need to know like what is the minimum value in a certain column and what is the maximum value and what are the outliers. Let's see why that's important. So these are the years of registration. They range from as early as 1941 to like 2018, and some like random values here. These are probably not years. These are probably some wrong values that were entered in the data. Like, I mean, like, well, creating the data set. or like typos. It could be anything. So that's why you plot the year of registration and price. You're seeing here, you could see that it's all concentrated around 2000, right? And all these are outliers. So here in this case, it will be ideal to just use the data points that are within this range. So this is basically you're filtering from like probably 1960 or 1950 to like 2018. So you just look at the distribution and you see what makes the most sense and what has the most number of data points, and you decide the working range 1950 to 2018. So this is a trial and error. It's nothing fixed. It just solely depends on your particular data set. So like that, we are visualizing every other variable as well. The price, like you don't see a box, it's just some line because most of the points they lie as outliers. See, everything is concentrated around zero. So this tells you nothing, and this doesn't help in prediction at all. Power PS, the same thing. Again, you don't see a box, it's just like a line at this point. Again, everything towards like zero. So looking at this, like such plots, you kind of decide what the working range one has to be like for Power PS. And like for Power PS, there are also like theoretical values. Like it has to be at least 10 whatever units for the car to start. The Power PS has to be this much. And the maximum Power PS a car could have is like this much. So you also take into account such theoretical limits and you filter your data accordingly. So that's what it's done. And here, so basically the year of registration, it doesn't matter. So what matters is how long has it been since the year of registration. So how do you calculate that? You just subtract the current year minus the year of registration. That will tell you the age of the car. So that's what we need. So that's what they're doing here. Yeah. So now after like filtering, setting your data range and filtering out the outliers, you are replotting the distributions. And now you can clearly see a box, right? Earlier, if you remember, it was just a line. And now you can see a box. So it tells you like most of the cars are like 10 to 20 years old. There are some cars which are like 35 for 32 years old. So this gives you like a clear picture. And same goes here. Again, it's like you could see a box and lower and upper limits. So like as such, you're now just visualizing all the parameters. So here price is visualized, age is visualized, power PS. And then now again, you're visualizing the relationship between age and power PS. Sorry, age and the other variables. Oh, no, sorry. Price and the other variables. So age and price, you can see early, like as this is not much. There are like as mostly you can see as the age increases, the price is also increasing a bit, but not so here it's not necessarily that case. So here even for 10-year-old cars, the price is very high, but still, yeah, it matters. So age is influencing the price. So this is considered as a significant variable. And power PS, it's like a clear, like increasing trend, like linear relationship. So as power PS increases, price also increases. So it's significant. So when would you consider a variable insignificant? So here we can see trends like, so in these plots, we are seeing like some trends. We are seeing trends like this. We are seeing trends like this. So this means that there is some relationship, like as this increases, and so on. Like, or it can be this. So all these are significant. So if some relationship is simply like this, what does this tell you? It tells that as X increases, Y is the same. There's no significant change. Or if it's like a very small like increase, that's also not significant. There is an increase, but it's not very significant. So this is how you look at the distributions and decide whether an independent variable is significant or not. So yeah, so here you're plotting seller. there is no commercial seller. Like there's only one commercial seller, and most of them are private. So this doesn't matter. It's not gonna decide anything. So this is an example of an insignificant variable. So this is also an insignificant variable. So there's no much difference between test and control. So if control box was somewhere higher like this, that then you could have said it's a significant variable and the price depends on this. But here it's the distribution is the same, so the price doesn't really depend on this. So here, this is a significant variable because you can clearly see that what are these models, like vehicle types, bus, car. So like each vehicle type, they have different price ranges. So that's a clear significant. This is significant to us. Yeah, this is significant because there is a good amount of difference. Yeah, basically that's how you decide. So this is significant because it's like as kilometer increases, price decreases. So that makes sense, except for this, which is an outlier in this case. But yeah, you can see a decreasing trend. So yeah, this in this example, basically it's just to highlight how to deal with so many variables and how to decide which is significant, which is not. Yeah, it's just the same plots done for all the variables. And we have decided these three variables are not significant. So we are removing them. We're doing all that. And then now we are using random forest model. So here, instead of using price, you're using a log transform price so that it's in like a narrower range, because the price, if you remember, it ranged somewhere between 150 to 150 something. Like that's a huge range, right? So when you log transform it, basically the distribution becomes like this. So it just ranges between like 0 to 12. You just make the range shorter. Like instead of here, like it's like very small price to very big values. Like here, 1,50,000, 100. So even here you could see that it's still like probably 40,000. So instead of that big range, you're just reducing the range by doing a log transform. But otherwise, everything else here is the same. Test, training, and then prediction. And then here we saw something called accuracy. Here we are looking at something called root mean square error. Root mean square error is basically how much deviated the point is from the fit line, the trend line, right? It's calculated using some Euclidean distances, like basically the distance between the actual point and where the I mean the actual like line where the point is supposed to fall compared to where it actually falls. So the range of this root mean square, it could be anything between 0 to any positive value, like positive infinity. So there's no particular limit for uh, root mean square error. So if you remember correlation, it ranges between -1 and +1, right? So you can have negative correlation and positive correlation, like 0.4, minus 0.4. But for root mean square error, there's no such limit. It's just from 0 to negative infinity. So a good model would have a very low root mean square error, like closer to 0 or even like 1 point something, like anything less than 1.5. So mostly the ideal thing would be anything like very close to 0, 0.4, 0.5. So that is a good root mean square error. So that's one more like model evaluation parameter. And we did so again, yeah, we're doing linear regression. Earlier we did random forest. No, did we? Yeah. So here we're doing linear regression. It's all the same steps. But yeah, all these like how to run, like what is the syntax, all that you have to remember. That's it. See, this is what something like, this is like a residual plot. this is good because everything is around zero. It's basically something like your error for each point. It's around zero, so it's good. Yeah, this is mostly the gist of it. So it's basically like the concepts that I explained in the beginning with the presentation. And yeah, you calculate matrices like this. Yeah, accuracy is one thing, root mean square is one thing, and R square, the correlation value is one thing. So what do you correlate is essentially your predicted value versus your test Y value. So if the correlation high, it means that the accuracy is good. So here you could see that with random forest, it gives a higher correlation. It gives you 0.8, 0.9 in trained data random forest. Yeah, so in both these cases, it looks like random forest is better than linear regression. So this is how you just compare multiple models and you see which is the best model for the data set that you are working with, and you just go ahead using that model. Okay, so now I'll just go through an assignment from a previous year. So you'll get similar problems in your exams. So it'll mostly be very simple. Yeah, we can have a look. Okay. Which of the following are regression problems? Assume that appropriate data is given. So if you remember, what is like regression is basically used to model categorical or continuous. That's what you need to think. Predicting the house price, regression. Yes, you can use regression for that. Okay. Predicting whether it will rain or not in a given day, that is not a regression problem. So this is no. Maximum temperature in a given day, again, it's a continuous thing. So yes, it is a regression problem. Predicting the sales of ice cream, again, that is a regression problem because it's like any value, like any number of sales could have happened. So yeah, like you just have to see which of these are classification problems, which of these are regression problems. So this is a classification problem. Okay, now which are binary classification problems? What is binary classification? The outcome can fit into either two categories. Predicting whether a patient is diagnosed with cancer or not. Yes, it is a binary classification problem. Whether a team will win a tournament or not, yes or no, again, it is binary. Predicting the price of a second-hand car, this is a regression problem. It is not even a classification problem. So, then classify web text into one of the following categories: sports, entertainment, or technology. This is a classification problem, but it's not a binary classification problem. It's like a multiple. Classification, but not binary, since it has multiple outcomes. Multiple as in more than two. Okay, so this one is if a linear regression model. Okay, I'll need my pen for this. If a linear regression model. This is basically linear regression model. If it achieves zero training error, like zero error means 100% accuracy. Can we say that all data points lie on a hyperplane in the d plus 1 minus dimensional space? Here d is the number of features. So here you just don't overthink. You don't even have to worry about this part. You just think. Can we all say that data points lie on a hyperplane? What is a hyperplane? So basically, this is a 2D structure, like x and y axis, two-dimensional. So for a 2D structure, a line would be the hyperplane, right? So if the model is 100% accurate, obviously like all the points, they fall on the line. So which means they all fall on the hyperplane. So the answer is yes, they all lie on the hyperplane. So in case of a three-dimensional object, let's say you have a cardboard box. You have a 3D object. In this case, your hyperplane would be one side of the cardboard box. Like you just cut this part out. That will be your hyperplane. So for a 2D object, a line is the hyperplane. 3D object, one whole like side is the hyperplane. So in this case, we are talking about this. So you think about it, 100% accuracy, all data points will fall on the line. So yes, this answer is true. Yes. Okay. So here these are actual like problems where you need to use Python. Read the information below and answer the questions from 4 to 6. Data. Okay. Okay, data description. An automotive service chain is launching its new service station this weekend. They offer to service a wide variety of cars. The current capacity of the station is to check 315 cars per day. As an inaugural officer, they claim to freely check all the cars that arrive on the launch day and report whether they need servicing or not. Unexpectedly, they get 450 cars. But they can capacity is 315, they get 450 cars. Servicemen will not work longer than the working hours, but data analysts have to work. Can you save the day for the new service station? How can a data scientist save the day for them? Okay, all this. Yeah. He has been given a data set. So the data scientist has been given this data set, service train.csv, that contains some attributes of the car that can be easily measured and a conclusion that if a service is needed or not. So basically what are they saying is that service station, they can service only 315 cars, but they get 450 cars. So the data analyst, he has to run a model and he needs to classify out of these 450, which are the cars that need service. So basically you predict, so X point is each car. Y is, does the car need service or not? Yes, no. That is why you need to predict Y. So like you can understand where this is going. So basically he has a test set. Now he has to run the model. Okay, let's just see the questions first. What? Use machine learning techniques to identify whether the cars require service or not. Read the given data sets. So they've given two data sets in the assignments, service train and service test, as train and test data respectively, and import all necessary packages for analysis. Question. Which of the following machine learning techniques would not be appropriate to solve the problem in the problem statement? Yeah, you can answer it on the chat. So this is basically a classification problem, right? We need to classify whether the car needs repair or not. I record it or not. Just a second, I'll check one thing. Did I start recording earlier or not? Like, yeah, I am not sure if I did that or not. Okay, anyway. Okay, so coming back to this is a classification problem, which is not appropriate. KNN is good for a classification problem, so this is appropriate. Random forest is also fine. Logistic regression is also fine. Linear regression is not appropriate because it's for regression problems. It's not for classification. So that is the answer. Okay, next. Prepare the data by following the steps given below and answer questions. Encode the categorical variable service. So they have a service column. You need to encode it yes as 1, no as 0 for both train and test data sets. And next task is split the set of independent features and the dependent features on both the test. So they already have splitted test and training, but they haven't split X and Y. The independent and dependent features, they haven't split it. So here in this case, independent feature would be service and everything else would be dependent. Sorry, the dependent feature would be service and everything else, let me write it here, Y. This is Y and everything else will be X. All other columns will be X. So they're telling to split it and then set random state as 0. So they're telling you to set random state also. So you first do all this, they're telling you to do all this, and then you need to answer the questions. Okay, let's first do all that. So so yeah, we're just reading the service train and service test CSV files as train data and test data respectively. We are just looking at what's in the data. So we could see all these are independent variables. Service is what we need to predict. You can see that there is yes and no. So we know that the machine will not understand this. We need to encode it as 0 and 1. So both test data and the train data, they have the same stuff. So yeah, we're just loading the libraries. Here we're encoding the service column. If X is equal to yes, it's 1, else you set it to 0. So you're doing the same for train data and test data. Okay, now next you're splitting the data into X and Y. So Y is just the service column. X is all the columns except service column. So you're dropping service column. So you did that for the train data. You're doing the same for test data. You're splitting as X and Y. And then you're initializing logistic regression with random state 0 because that was given in the question. Okay, now what is the question? After applying, we did till this. And then after applying logistic regression, what are the correct observations from the resultant confusion matrix? So you need to look at the confusion matrix and you need to see which is correct. So we're doing that. To make the confusion matrix, first of all, you need to like predict Y. You need to fit the model, you need to predict it. So you run all these steps. You calculate accuracy. Oh, I don't know why did I do that. Yeah, because the next question is accuracy. So the next question is they're asking what range is accuracy. So we have also calculated accuracy here. And then we are also, there is confusion. Okay. Okay, in this part I've just calculated the accuracy. We are getting 0.91. So the answer to this question would be option B. Accuracy is falling within this range, right? So that is our answer. Accuracy is done. Here, but next one, confusion matrix. We are doing it. So this is the confusion matrix. So what does this tell you? True positive is 94. True negative is 29. False positive is 5. False negative is 7. Right? Now look at our options again. Option 1, true positive 29. That is wrong because true positive is 94. So option B is correct because true positive is 94 and true negative is 29. But there could be this could be multiple answers. So you still look at the other options as well. False positive is 5. That is also correct. False true negative. Oh, this is wrong. Sorry. Yeah, then it's just this is the correct answer. Yep. This is your correct answer. Let's say if they had this. If they had this as an option, you'll have two correct answers. Because false positive is 5 is correct. True negative 29 is also correct. Okay. So this is how you go about such problems. You need to look at all options. You need to know how to generate the confusion matrix. You need to know to read it. Okay. How are categorical variables pre-processed before modeling? Oh yeah, I missed mentioning this, but yeah, it's called dummy variables. Like if you remember, the native country was Portugal, Taiwan, Thailand. So we just split that into dummy variables called native country underscore Portugal. So yeah, how these category variables are pre-processed as dummy variables. Okay, that that is over now. They've given another data set with different set of questions. The Global Happiness Index report contains the happiness score data with multiple features, namely economy, family, health, and freedom. So you can from this you could tell that the dependent variable is happiness score, and your independent variables are economy, family, health, and freedom. So prepare the data by following the steps. Split the set of independent features and dependent features. Create training and test data from this. Split using the ratio 3:1 and set the value for random state as 1. Okay. Basically the same thing that you did earlier, you do same thing. So you read the file, what is the RMSE? Okay, this is it. I'm reading the Global Happiness Index report. So why I'm splitting it as H score? So we see H score, all this freedom. So I just want to predict this. So this is Y. All the other columns are X. Now we have X and Y. And now splitting X and Y. So 3:1 ratio. So which means test data is just 1/4, which is 25%. So 3:1, 1, 2, 3. All this go to training. And this goes to test. So this would be 25%, right? So the test size is 0.25, 25%. And then the question they mentioned, what's my face showing? the question they mentioned random state is equal to 1. So we are using all that information, we are splitting the data, and then we are building, have they mentioned to build linear regression? Yeah, they've mentioned linear regression. So you build a linear regression and you calculate RMSE, you get 0.46. So that's closest to 0.5. Like if you round it off, it's 0.5. So this is your answer. Okay, next question. A regression model with the following function y is equal to y is equal to 60 plus 5.2 x was built. So H score, we are not calculating H score. H score is already given. Like this is part of the training data set. It's the happiness index. So if you know, like you would have seen statistics like world's happiest country is Finland, right? So how do they calculate? How do they say this? How do they say this statistically? How do they say Finland is the happiest country? So they look at several factors like work-life balance, like freedom, health, like how much money they have, like how much they're paid, economy. That's what they mean by economy, family. So this happiness score, happiness index is calculated using all these like parameters. We like right now we don't know how it's calculated, but it's just that your data set. You have a training data set. You're just trying to predict happiness score for a test data set. So what you're doing is you're splitting your given data set into training and test data. You're building the model using the training, and with the test data, you're supplying that to your model. And that test data is not actual test data. You know the actual happiness score for that test data also. So you're comparing the predicted value of happiness score with the actual value of happiness score to tell if your model is performing well. So that is the main goal here. So yeah, that's what happiness score is. It's just similar to like price. In the example, you had price of the car, kilometer, age, all that. Something similar to that. Okay, what were we doing? We were doing this. A regression model with the following function y is equal to 60 plus 5.2x was built to understand the impact of humidity on rainfall. So yeah, this is also one example. You can predict rainfall based on several other things like humidity, precipitation, cloud cover. Yeah, several other like independent variables to predict rainfall. So in this case, we're looking at humidity. So this is of the format y is so if you look at this equation, it's of the format y is equal to mx plus c, right? So it's basically here the slope and intercept. So m is your slope, c is your intercept. Like if you look at it mathematically. So, but what is the question? The humidity this week is 30%. No, not percent. Humidity this week is 30 more than the previous week. So, X is basically 30 more. Humidity is 30 more than the previous week. What is the predicted rainfall? So, actually, they've given X value is equal to 30 and you want to predict Y. So, it's straightforward. You just, in place of X, you substitute 30. So, 30 into 5.2 plus 60. So, that will be a Y value. So now you just do the same with Python. Intercept. Yeah. You remember, right? Y is equal to mx. M is the slope. So slope is equal to 5.2. We are defining it here. Intercept C is 60. Humidity change, which is basically our X is 30. So rainfall difference is y, which we need to predict. So we basically do slope into humidity. You need to calculate the rainfall difference. You don't calculate the rainfall. You just calculate the difference. So that's why you just do this into this. 5.2 into x. So you run that, and now the predicted difference in rainfall is 156.00, like whatever units it is. If you look at our options, yeah, 156 millimeters. That is our answer. Okay, I think this is the. Okay, I've just given a summary here. Uh, Before that, okay. The last question is x and y are two variables. Yeah, sorry. X and y are two variables that have a strong linear relationship. Okay, again, with a linear relationship. Which of the following statements are incorrect? There cannot be a negative relationship between two variables. This is correct. Oh, they're asking which is incorrect. This is correct, right? Because linear relationship, it always has a positive correlation. So there cannot be a negative. This is correct. The relationship between two variables is causal. By causal, it means like y is dependent on x. So it's purely because of that. One variable may or may not cause a change in the other variable. The variables can be, okay, this is also true because one variable may or may not cause a change in the other variable, but we're just looking at two variables, right? This is also incorrect because linear relationship means it's clear that one variable changes, the other also changes. This says may or may not cause a change. So this is incorrect. Variables can be positively or negatively correlated with each other. This is also incorrect because it is positively correlated. So yeah, that's it. So this is how you can expect your problems, assignment problems. Can we get past your assignment? I don't know about the main exam question paper, but what I can do is I can just upload the past year question papers like week 1, week 2, week 3, week 4. Just 4 assignment questions. I could upload it to the drive where I upload this material. Let me reshare the link again. Do you know when is your exam? Live session materials and assignment questions with solution. Oh, okay, I've shared the Google Drive link. September 21. Okay, you have good enough time. Yeah, so I will be uploading this by tomorrow. Like all this I'll upload by tomorrow. And you'll also have today's recording tomorrow. Like morning. Tomorrow morning when you wake up, you'll have the recording on YouTube. Wait, let me. I am not sure about like appropriate textbooks for this level of the course, but I think some additional materials were already provided on the website, right? Those, like, if you go through those, that should be good enough. Like, if you look at, no, not this. Will the questions in the exam be MCQ or written? Exams will be MCQ. Like, it'll be like your assignment problems. So, yeah, MCQ. I'm just trying to fetch the materials. Can I use Colab Google? Yes, you can use Google Colab. That is good. That is a very good option because, like, in Google Colab, you can use Jupyter technically. Google Colab is basically, it runs on the cloud platform. So that means, like, some of you had the problems like when you run Anaconda Navigator or when you run Jupyter Notebook, your computer gets crashed. Why does it get crashed? It is getting crashed because it's using your computational resources. So your computer might not have enough memory to handle it. So in that case, you can run it on Google Colab. So it just uses cloud resources. I think 8 GB memory, or I don't know how much memory it uses, but yeah, it has like free storage that you can use and memory as well. And yeah, it's technically like Google Docs. Like everything is saved in the cloud, right? And same, you can actually run it there. Yes, I will share, like, I will share this. Uh, I'll share the PowerPoint that I was just writing, explaining things on. I'll share that, and I'll also share this Jupyter notebook. I'll upload it now. I try. Yeah, you'll find the materials in this. You can use Google Colab. So mostly, yeah, I'll confirm this, but in most cases, in exams, you will not be able to run any program. So mostly you'll just have theoretical questions. So like in scenarios where you have to run, like for example, this question is asked. N- what they'll do is they'll probably give you a screenshot of this confusion matrix. They'll give you this. So from this, you have to figure out what is the answer. So that's how mostly your exams will be. I am not exactly sure, but this is how like most of the courses have been, like other courses. Like you can't run it, but yeah, like your question paper will have like hints for you to like figure out instead of running the code. Yeah, I will confirm this. I'll probably post it on the discussion forum. I'm not sure because all this like setting question papers, some like a different group of people they do it. So yeah, I have no idea about that, but I will confirm and let you know. Okay, I was trying to look for materials to read. See, here, oh, you cannot see my screen. So here, there's something supporting material for week 4. So I think if you go through the materials that are provided, that should be good enough, like for this course, and to understand better the concepts as well. Because like the lectures there were just very brief, like just giving you an overview of these and telling you how to run. So these materials, these should be good enough for you for now. I don't know if the other weeks, like just like dealing with data. Yeah, only like in week 4 you have supporting material, like reading material. So basically, like week 1 to 3, they were all basics that were building up for you to perform week 4, right? So I think these should also probably cover like data cleaning and all that. Like, I'm not sure about anything about the exam marks. Yes, it is MCQ that I'm sure of. About whether you can run Python, you'll use computer, that I don't know. That we'll have to ask. I don't think there's any such thing as important question. So it's just gonna be like simple concepts. Basically, like if you just read and understand well, that should be good enough for you to answer. Like you don't need to know hardcore coding or anything to answer. You just need to know probably like whatever we have done so far, what that command does. Like for example, let's say, yeah, they might probably, so like one just example on top of my head is like they can give you this line. They can ask what does this mean? What does this mean? That is one thing. Or they can ask like, what does this do? Like what is this function? Like just such things. So if you just understand what we have done and what lines we have used and why we are using it, that should be good enough. Yeah, I will confirm that. I don't know how much marks it will be. It could be 50 or 100. And usually it's 3 hours if it's 100 marks. That much I know. But yeah, I think like closer to your exam dates, like all this information like will be given. Where you have enough time to prepare as well. Like you have a month. Protocol exam questions, I like right now I have access only to last year's assignment questions. But yeah, I can just try asking other people, like other TAs, like the people who set the question papers. I could ask them if they can share. But yeah, it's up to them if they will share protocol exam questions. But last year's assignment questions I can share. Yeah, I'll upload that on the drive. I think this is the last session. Oh, yeah, this is the last session. There might be four, I don't know about that. We haven't got any information regarding that. So, like, you have 4 TAs for this course. Each TA might have one extra additional hour. Mm, I think, yeah, all these evaluation related questions you have to like ask on the discussion forum. Yeah, because like we don't do the evaluation, and you can ask somebody there, and the people who are responsible for this evaluation, they will get back to you. Yeah, in case you didn't have my YouTube channel link, not this. Recordings. Oh, sorry. All right, like all these will be shared by tomorrow. Like I'll upload the recording and I will also upload last year's all the assignments and this one. I have no idea about that. About the assignment deadline, it's probably given on your website, right? Week 4 assignment, practice, week 4 assignment, week 4 assignment. Yeah, I'm not sure about that. Oh, it's given here. Your due date is 21st. Oh, which is basically tomorrow. Tomorrow is the deadline for your assignment. My LinkedIn. It's been so long since I opened that LinkedIn. But yeah, let me share. Mm, Yeah, I haven't updated this in so long, but it it's probably 50 or 100 marks, the exam. I'm not sure. It depends on whoever sets the question. But yeah, if it's 100 marks, you'll be given 3 hours. Okay, I was. I like for the exam, I don't have any reference format. I have to ask other TAs on the discussion forum, and yeah, if they share it, it's good. Or if they don't, yeah, I'm not sure. All right. Yeah, the live session will be available tomorrow. And yeah, like I'll get back to you with the exam format and whether you'll be having access to run Python and question paper format. All these I'll try asking other people on the group tomorrow. And yeah, if you keep following that, you'll find it there. All right. Yeah, if I find any other good book, I'll also upload that here. But for this course, for now, you don't need anything. I think these reading materials that are provided here, where is that? Supporting material for week 4, these should be good enough, like to understand, like for this level of the course. Yes, I will confirm this, but this is how it's been. Like last semester, I was a TA for our like another 12-week course. So that was a 100-mark exam, but that involved a lot of problem solving. Like it was all mathematical. But yeah, in this case, you won't have all that. So it's probably like a shorter exam. But I'm pretty sure like most probably you will not be able to run anything. But yes, I will confirm it. All right, I'll get back to you like tomorrow. Like by getting back, I mean I'll post it on the discussion forum and yeah, you'll have to follow it up. All right then. All the best for the exam. I'm not sure if we have one more extra live session, but if we have one more extra session, you will be updated on the email. So yeah, if we have that extra session, see you then. Otherwise, yeah, all the best. Thank you for joining. Yeah. All right, I'm logging off.